Very good.
Okay, so Trig, we're into 5/7's world again. People that are in physics, this is somewhat of a duplication of the things you've been doing. People not in physics, this is all brand new to you, so I'll try to talk more to you than anybody just because this is brand new to your life. But even people that are in physics, there's some differences in the way the Trig book presents some things compared to how the physics book does. But largely this is a replication. So vectors is the title of the next couple's worth of days worth of materials. So vectors are just a thing that have a magnitude, meaning a size, a number, and also have a direction, like north, south, east, west, something like that. What we're going to be looking at in the next week or so in here, as well as in physics, is that vectors get represented by rays, meaning arrowy looking things. The magnitude is a word that refers to the length of it. And then the arrow is going to show you the direction. Vectors can be equal. Vectors can be equal only if they have the same magnitude and the same direction. And our book has the same abbreviation at first as the physics book does. If we have this mystery vector that we need to use a variable on, call it x, if they want to show you that that's a vector, they can put a little hat on there that looks like an arrowhead, or sometimes they only draw half of the arrowhead just to do that. A new abbreviation for everybody's life other than mine, when they want to talk about the magnitude, the length of a vector, they're going to do that with what looks like absolute value bars. So when you see in your homework something that looks like this, that has nothing to do with absolute values. That's just asking you for the magnitude, the length, the number that goes with the vector that they gave. Some examples of vectors just from physics life or regular life. If I say we have a displacement of 20 miles east, that becomes a vector as soon as I say east, because vectors have direction. If I didn't say east, it's a word called distance. I traveled a distance of 20 miles. No direction, that's called a distance. Velocities are a vector, like I drove 30 miles per hour west. If I just said I drove 30 miles per hour, that's not a velocity, that's a speed, which is a slightly different, close to synonymous word. There's another category of words called scalars. Scalars just have magnitudes. So if I go back to what I just said about the distance being 20 miles, or the speed being 30 miles per hour, and don't say a direction, that's a scalar. Up until this moment of your life, everything has been a scalar, but in physics life, we've had some things lately that are vectors. So far, that's just information. We haven't really done anything mathy with that. Anybody a question about what I'm saying so far? In Trig world, earlier in the year, we did a scheme where we had angles in standard position. So where was 0 in our angles in standard position world back then? To the right. To the right. So this is 0 degrees. Where was 90? Top. This is 180, 70, 360. So if I traveled like here-ish, what angle roughly am I moving? About what number would that be?
About 220 or 200.
210, 220, something like that. Because I'm more than 180, I'm less than 270, I'm closer to 180, ballpark that, 210. The Trig book at times will give us directions like that. Okay, people that are in physics, what they would have been saying in physics would be, we'd have to take the 210 and the 180 and figure out that the difference was 30. This is what direction? West. This is 30 south of west. Or we could have figured out that's a 60 and we're 60. What of what? West of south. The Trig book will never do what the physics book is doing. You're not going to see anything west of south, north of east. They don't even acknowledge that. They'll sometimes just go with, instead of saying 30 west of south or the 60s or whatever we just said, They might just say standard position angle 210. And that sends you the same place, it's just a different way to describe it. They're also going to do a whole new system called bearing. Bearing puts 0 at the top at north, and instead of going counterclockwise, they measure bearing clockwise. So this is 90, this is 180, this is 270, and this is 360. So if I headed in that exact same direction, this, we saw 180, we saw 270, we guesstimated this as a 210. What bearing would this be? Yeah, if I tried to do the exact same match where I had like a 30-60 like situation, this would be
240.
240. They're going to do that exclusively. Tonight's homework, I think, is all bearing, maybe, or maybe it's a mix of these two. I'm not sure. We'll look at that in a minute. But bearing is a new scheme to adapt to. So if I said to you, here I go, this angle is 10. What bearing is that? 80. Because it's 10 away from the 90 line. Or I could say to you, this is the 10. Now what bearing is it? 10. Because we're 10 away from the 0 line. I could go here and throw you a 10. That is now 280. A different voice. Picture not drawn to scale. That's my 10. Where would we be pointed toward?
350.
How much 50?
350.
350, I agree. Question about that concept for directions?
It's safe to say it's like exactly like a clock, but multiplied by 30.
Yes. Okay. I've never had someone ask that before, but yes. Question about front side of notes. Okay, as we flip the side, if we're going to add vectors, not news to anybody's life who's been through physics, but news for our other customers. If we're going to add vectors, you have to get them positioned so they're head to tail. By the head, I mean where the arrowhead is. By tail, I mean the part that doesn't have an arrowhead. So if I say, here's a vector I'm calling A, here's a vector I'm calling B, the way I'm going to have to do that is to like jam these together to have A go here and B go there and have them touching. Just sort of jam it together so we have a thing that they're positioned head to tail. Then there's a thing called the resultant, which is where the answer is. When I draw this dotted thing in, this is the answer for A plus B. This was A, this was B. This third side I just created is A plus B. New thing to everybody's life is subtracting vectors. If I want to do A minus B, if this is the B vector going right, that would be a negative B vector. It just goes left, just goes in the other direction. If I want to go and do A minus B, it would be a similar picture. The A is going in the same parallel direction as all the other A's I've drawn on the board. But if I'm going to subtract B, instead of going right at the head, I'd have to go left. So this would be a picture of A minus B. Take the A direction, but B goes another way. Question about that? Okay, so here comes a homeworky kind of problem. So homeworky problem number 1, it says if the magnitude of A is 4 and the magnitude of B is 9, and the angle between them is 27, I'm going to ask us to do a bunch of stuff. So here's a vector A that was, what was the number? 9? 4. Here's a vector B. That one was the 9. And the angle between them was 27? This is right now not a very good picture because those vectors are not positioned head to tail. We have to get the vectors positioned head to tail. The directions ask for 4 things. To do A plus B, find the magnitude, find the direction, and then A minus B, find the magnitude, find the direction. Well, when it asked for directions, it said find the angles they make with A. So let me make sure my picture on the board is decently matched with the picture. See if that works for the one on the next. So to do A plus B, I'd leave A alone. At the head, I'll draw the B. So this was a 4. This was a 9. These two things are what geometry were. Parallel. So geometry flashback. Parallel lines. This thing is called a transversal. If this is 27, this would be 27. What would this be? 27. What would this be? What are these called? Anybody remember? Start with a V. Vertical angles. The other 4 all match each other. What number would that be? 153. The angle that we care about, is it a 27 or a 153? It's a 153. So what I want to do is find this side, and I want to find the angle with A. Which number was the A?
4.
The 4. So that's the angle that I want because it's the angle that touches 4. It also so happens to be the angle where I started to draw, but notice, unlike physics, I wasn't super emphatic on the starting point for this. Like, I didn't care about that as much because it specified the angle with A, and I know that A is 4. I know to look for the one that touches the 4. And then we run a program, or do law of cosines, or do law of sines, or do something that we've been doing with triangles, and it should shoot the answers that are on that paper. And then we're halfway done. Why are we only halfway done?
You have to do the same thing, but with A minus B.
We have to do the same thing, but with A minus B. An A minus B picture would also have the 4, but instead of the 9 going right,
Just like
the 9 goes left. Dot, 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 dot. I need to know how long this is. And again, I want the angle with the A. So I want the angle that touches the A. So that would be that one, because the A was the 4. What was this one? Would this be a 27 or a 153 if we were going,
27.
it's back to the 27 again. Run a program, it should get the answers that are on the page. Anybody, anything, something about that part of it? So here's a different version. They're going to give us 2 vectors and want us to add them. So it says we're going to travel 90 meters south, and then we're going to travel 40 meters at a bearing of 250. So here's where I go back more to my physics feel. I am definitely going to stress, let's make a dot for the starting point of our drawing on any of the stories where there's like a traveling man of some sort. So here's my starting point. I'm going 90 meters south. So south goes down. At the tip, I'm then going in a weird direction. So I'm going to draw myself a little bit of a bearing type coordinate system. If I'm gonna now travel at a bearing of 250, check our bearing cheat sheet over there where I accidentally erased a smidge of it. If we're traveling at a bearing of 250, am I up left, up right, down left, down right? Where's a bearing at 250?
Down left.
I'm down left. Okay. What I need to then figure out is this angle piece. Okay. If this was 250, what's this line? 270. How much is this? 20. But when I go to do a triangle, I'm going to need the full entirety of that. How much is that? 110. Anybody mad about that?
You also figure it out by like, this is a 250, we need to make 360.
You can do 360 minus 250. In that one, yeah. Something
Why is the whole thing 110?
because this little sliver was 20, because from 250 to get back to 270 is 20. And then this part is another 90.
Right. Okay.
Is it okay? Question there? I'm going to clear a little bit of stuff out that I don't need at this point. And what we're trying to do is draw in a thing called the resultant from the starting point to the final head. I'll always want to know the side there, and I'll always want the angle at the starting point if I had a starting point to my drawing. What didn't I label on here that's helpful?
The sides.
The sides, yeah. This side was
90.
90. This side was 40. Quickest way to do this is run an SAS program. We're going to get the side, no problem. We're going to get the angle of 19. But the bearing is not 19. But I'll just pause there. Is there anybody bothered by like the program running, turning out a 110 and a 19? So we have to kind of think about where we are. Maybe one of these helps us. Okay, that was where we started. We just came out with a 19. So we're like in here somewhere. That's the direction we just moved. The dotted line went this way, and we just uncovered a 19. How are you going to figure out where we are? 19 plus 180. We're past 180, headed toward 170 in the direction where things get bigger. We'll have to take 180 plus 19, and that's going to get the answer that I circled on the page. Question about that? Let's take a peek at homework. The homework will be in two parts. One, I'm going to give you a sheet in a second where I'll do things like drop you in a random quadrant. Let's do one more practice problem of that. Pick a quadrant, any quadrant, 4. So I drop you into quadrant 4, and then I'll label you at the angle either above or below. Pick one.
Below.
Below. Pick any number that's like under 90, 40. And then we'd have to figure out where we are. If this is the 180 line, and this is the 90 line, where am I? I'm at 140. Because I'm headed less than 180 to get back toward the 90. I'm 40 away from 180. I'd be sitting at 140. What if somebody had yelled, go above? Now where am I? 130. So there's a worksheet of those because that's going to be a necessary basic skill for our chapter. So I'll drop you in all different sort of diagonal things with different labels and have you do a paper of that. Then the longer part of the homework that'll take more time, even though it's not as many problems, there's 16 on this, but these are a quick hit. There's a homework on 162. 162 has a 1 to 8. 162, 1 to 8 is like what I did on the board. This first problem, there's 4 of those. 1, 2, 3, 4 is like this. They'll give you a description of 2 vectors that the original drawing would be a tail-to-tail drawing. And then you're going to have to remake things to do an add, remake things to do a subtract. And then 5 through 8 is more like this one, where they're going to send you one direction, north, south, east, west, and then they're going to send you some sort of a weird direction somewhere. Anybody, anything I can do to serve?
How do we know exactly when to add and when to subtract?
You just have to think. You could try to memorize like the rules. There'd be 8 rules to memorize, because this would have 2 different scenarios. This has 2 scenarios. This has 2 scenarios. This has 2 scenarios. So you could either try to memorize 8 rules for 8 scenarios, or you could just draw the picture and think about it. Basically, if you're moving in this direction, things are getting bigger, so add. And if for some reason you're moving in that direction, things are getting smaller, so you subtract. So, like if I give you this number, you're moving away from a known 180, getting smaller, so subtract. If I told you this number, you're moving away from a known 90 in a direction where it gets bigger, so you add. But there's not like a surefire, just add or subtract. Like you just have to draw it and think about, you'll always be touching one known line, and then you add or subtract depending on where it's going. Here's another thing that just spooks people. For bearing rotates and counts bigger as you go this way. Standard position angles get bigger as you go that way. So in scenarios up till now that you're used to getting bigger and adding, you're going the other way now, you're subtracting. It is what it is. Something else, anything, anybody? Yay, we're done.